Hi guys, in this video we are going to talk about the lighting protection, lighting system. Yes, we need to protect our boat during the storm, during the hurricanes, for lightings. And what is the function of the lighting protection system? The function of the lighting protection system is drain excessive amount of electricity from the environment directly into the ground and protect our boat. In other words, is drain excessive amount of static electricity accumulated on the clouds, and that electricity should be drained directly into the water and the water with the ground. How can I protect my boat for lighting protection? Two elements are important. One is the bonding system. If the bonding system in your boat is perfect, the bonding conductor, the sinks are properly installed, your boat is protected. If additionally to the bonding system, you have another lighting protection system working together with the bonding, your boat is properly protected. You remember when I explained in a previous episodes how the static electricity is produced? The static electricity is produced basically when you have an appliance with the internally electric motors, AC or DC. When the motor is spinning, when the motor is running, some electrons jump into the case of the dishwasher or the appliance, and that electricity, those amounts of electrons are accumulated on the case, and this is static electricity. If your appliance is properly installed, your appliance have the green cable connected to the ground, and the static electricity drains properly. The name of that green cable is the bonding. In that case, your equipment, your appliance is properly bonded with the grounding system. Okay, is static electricity. What happened in the clouds? In the clouds, the clouds is basically an element like a battery, and the charge, the positive and the negative charge, are separated. Normally on top of the cloud, the positive charge are located, and in the bottom of the cloud, the negative charge are located, like in the picture that you have on the screen right now. Your boat is under the cloud. And what happened during the storm is the cloud is pretty close to your boat. Okay, that amount of static electricity try to drain into the ground, try to go down, especially because in that moment during the storm, the environment have too much humidity, and the humidity and the temperature is a good path to drain that electricity. All right. What happens if two clouds are approximating? One cloud here and the other one. Remember, in the bottom of this cloud, you have negative charge. In the positive of this, you have positive charge. What happens when the bottom of this cloud is pretty close to the top of this cloud and a small arc is produced? This is the lighting. This is the lighting. And this is the lighting that tries to go down. If you check on the picture, what happened with the surface of water below the cloud in that area? That surface become positive. That's incredible. It's positive, the surface of the water below the cloud. All right, for that reason, the lighting tries to go directly into the surface of the water. How can I protect my boat in order to drain easily that amount of electricity? with a good lighting protection system. Normally, you hear that the electricity try to follow the path with less resistance. This is true. That's true. But before the electricity is taking the path with less resistance, the electricity try to return to the source of the power. If you have a leak of electricity, that leak try to return to the source of the power. You remember the sources of the power? Okay, exactly. On the back end of the generator or on the inverter. If you open the case of the inverter, the neutral and the ground are together over there. And if you open the back end of the generator, the neutral and the ground are together. If you open the transformer in front of your home, the neutral and the grounds are together over there. And after that, one cable continue neutral and other separated from the case of the transformer or generator or inverter goes like ground. And after that, those cables are separated all the time. And internally in the boat, the negative bus bar and the neutral bus bar shall be separated, never to get there. You remember the video, the previous video? What happened if for some reason you have reverse polarity? If you have reverse polarity, it's because you switch in the AC panel the neutral with the hot. And right now the neutral bus bar is hot and the hot bus bar is neutral. Oh, the neutral bus bar right now is hot. What happened if some industrial technician, no marine technician, install an equipment in your boat and suddenly connect the neutral and the ground, and right now the neutral is hot? Oh, my ground is hot and my bonding is hot. If my bonding is hot, 120 volts or 240 are moving in my bonding system. What happened with the metals connected to my bonding system in my boat right now? Those metals are powered with 120 volts AC. What happened when you have two dissimilar metals together in a marine environment? This is galvanic corrosion. Yes, because each metal have a different level of energy, different electronegativity, and a small arc of electricity is produced in between both metals. This is galvanic corrosion. What happens if you have the same two different metals together and additionally a current passing through those metals? The corrosion is accelerated. This is electrolysis. Electrolysis is galvanic corrosion plus an external current. Simple. All right? For that reason, it's catastrophic if you have the neutral and the ground bus bar together in a boat and additionally reverse polarity. That's catastrophic. Okay. Yes, if you have a leak of current, that leak of current tries to return to the source of the power. For that reason, this picture, the picture that you have on the screen right now, is a wonderful picture. In that picture, it's clear what happened if the ground is broken. If the ground line is broken, the static electricity storage, in the case of equipments, try to return to the source of the power through the shaft or through the propeller, increasing the electrolysis of exposed metals. This is a nice picture, and this is a clear picture about what happened in that case. Okay, for that reason, it's important that the connection in between neutral and ground be only at the source of the power. Okay, we are going to continue with lighting protection. Lighting protection is the combination of a vertical movement of water drops and the currents of air produce bigger amounts of electricity moving in between the clouds trying to get the ground. This is the phenomenon. Remember, those lightning strikes, the voltage on those lightnings is more than 100 millions of volts. More than 100 millions of volts. This is a lot in comparison with the voltage that you have in the hot lines on the transformer in front of your home, 12,000 volts. It's 100 millions of volts. and that excessive voltage try to reach the ground. If the lighting found a boat is easy drain through the mass of the boat and touch the ground. For that reason, we need to protect our boat properly in order to help that the drain of that current be easy and don't touch internally our boat. What is the idea? The idea is this. If you have a good bonding system, if you have an excellent bonding system, everything, all the metals are connected with the bonding conductor, and the bonding conductor finish into the sinks in the transom that you have on the screen right now. Through those sinks, you drain the majority of the static electricity accumulated on the equipment, or in some cases, you drain a short to ground of AC or DC current. Those excessive currents or static electricity currents are drained through those pieces of sinks. What happens if during the storm you don't have a piece of metal, a rod of metal on top of the boat in order to concentrate the lighting and drain the lighting directly into the sink? If you don't have that piece of metal, that rod, the lighting try to reach any metal on the boat, normally the rail or the anchor. And what happens if the rail or the anchor are not connected to the bonding? Oh, that piece of metal receive 100 millions of volts and destroy the fiberglass, destroy the boat, and produce a hole, and the boat is sink. That's the situation. Okay, if the rail is connected to the bonding, if the chain of the anchor is connected to the bonding, receive the excessive amount of volts and drain into the bonding, and the bonding drain into the sinks. That's the situation. For that reason, you know, in some moments in the bonding conductor, normally the current is a small DC current, but in emergencies, in the bonding conductor, you have millions of volts, and those millions of volts goes outside through the sinks. For that reason is the recommendation, never use the bonding conductor like a ground to connect equipment, to connect bilge pumps. I remember in a boat some years ago, one technician connect the bilge pumps on the engine room, the ground connected to the bonding system. And during the storm, during the hurricanes, those 3 bilge pumps explode. That's not good, all right? Be careful, never use the bonding conductor like a ground to connect equipment. That's not accepted. All right, okay, if my bonding is good, okay, my bonding can help during the storms to drain excessive amount of currents. All right, but in order to avoid use the bonding to drain that excessive amount of energy, it's good idea create other paths separated from the bonding. At the end, both paths are connected and drain together. But it's good idea create other additional path. That path start with the mass rod, like you have on the screen right now, and the mass rod is connected directly with a new plate similar to the sinks on the transom. This plate is the lighting protection plate. The name of that plate is the Dyna plate, like the picture that you have on the screen right now. The Dyna plate, the area of that plate should be no less than 1 square feet. This is the ABYC question. What is the area for the lighting protection plate? Is no less than 1 square feet. And what material is the material for that Dyna plate? Is a special corrosion-resistant alloy. Is copper, bronze, or mono. It's a special alloy. The color is like a bronze. Is like a gold. Is the different like the zinc plates. The zinc plates are the color of those zinc plates is silver, And this one is like a copper bronze. It's an special color. The name of those plates is a dyna plate, and those plates are connected with the conductor, and the conductor is attached directly to the rod metal. What is the gauge of the conductor? The gauge of the conductor should be number 4. And what about the metal? The mass? The mass, the top of the lighting rod should be 6 inches above anything else on the mat. And at the end should be sharp in order to concentrate the electricity at the end. Okay, and this is the picture of a good connection in between the rod, the conductor, and at the end the lighting protection plate. What is the recommendation with the lighting protection plate? The lighting protection plate and the sinks on the bonding should be connected together. In other words, both of them are connected at the end, and both of them are used to drain excessive amount of current. But the idea is install a separate plate. Normally that plate is located on the side of the boats or sailboats, and the color is a little different like the sinks on the transom, and the function is drain excessive amount of currents coming from the storms during the lighting process. And both of them drain on the ground, and both of them are connected to the bonding system. And don't forget the difference between a galvanic corrosion. Galvanic corrosion is when you have two dissimilar metals together in a marine environment. That's galvanic. And electrolytic corrosion is galvanic corrosion plus an extra current. This is electrolytic corrosion. Okay, I hope that this concept, the concept of the lighting protection system is clear. The lighting protection system is an extra connection in order to drain directly any excess of electricity coming from the storms lighting, drain those lighting directly into the ground through the separate plate. At the end of the day, that separate plate is connected with the sink plates, and both of them are used to drain excessive amount of DC current. DC current. That amount of electricity, 100 million of volts, is DC, is not AC. Remember, AC is only produced for rotation of electromagnets. The rest is DC. That's okay? The current that you have on the clouds, the current accumulated on the clouds is DC current. The current that you have on the metal case of your appliance is DC current. The current produced for the solar panels is DC current. The current storage on the batteries is DC current. AC current is only produced for rotation of electromagnets. Mr. Lopez, what happened with the inverter? The inverter is not a rotation of electromagnets and produce AC. Yeah, that AC current is a special rectified current coming from an electronic circuit board. This is a fictitious AC current. It's not real AC current. So you remember, it's fictitious. I am going to explain later in chapter 15. It's fictitious because that current doesn't have frequency. Okay, my friends, I hope you enjoy this video. Thank you.